So this is based on very, very basic problems of uncertainty. Let's see the question. Consider an individual A with the utility function u is equal to 10 root x. So ux is given as 10 root x, where x denotes the amount of money available to her. Suppose she has 100. So this is the wealth given of the individual, which is 100, which is represented by x. So let's write x only. However, she has an option of buying lottery that will cost her 51 rupees. So the cost of lottery, this is 51. And it says that if purchased, the lottery pays 351 with probability P. So which means that with probability P, you get 351. And 0 with the remaining probability. With probability 1 minus P, the lottery pays 0. And the lottery is purchased out of 51 rupees. Remember that you're not spending your entire money. You're only spending 51 rupees. Okay. Assume that A is expected utility maximizer. Which of the following statement is correct? So first of all, because A is maximizing expected utility, the first thing that we must do is find expected utility. So let's go ahead and do that. So my expected utility is probability that I win the lottery into my utility from winning the lottery plus probability that I lose the lottery into my utility from losing the lottery. This is going to be my expected utility. Now just see P. What is my utility function? It's 10 root x. So I will just use this function as is 10 root x. Now what is x? X is the money that I have with me. So the money that I have with me when I'm winning, I had 100 rupees. I went ahead and I spent 51 rupees to buy the lottery. And because I won the lottery, I won 351 rupees. Plus 1 minus P. My utility function is 10 root x. So 10 root. Instead of x, I will write the payoff when I lose the lottery. So I had 100 rupees. I spent 51 to buy the lottery. And I won 0 rupees because I lost everything. So this is going to be P 10 root, it's going to be 49 plus 351, so 400 plus 1 minus P 10 root 49. So this is going to be P 10 into 20 plus 1 minus P 10 into 7. So 200p plus 70 minus 70p. 130p plus 70. This is going to be my expected utility. Now, once you find your expected utility function, it is asking you find out, assume A is expected utility maximizer, which of the following statement is correct? Which means when will A go ahead and when will A buy the lottery? So once I find out this expected utility, now just think about this, okay? A will buy the lottery when his utility from buying lottery, it is greater than the utility from not buying lottery. Not buying lottery means what? I had 100 rupees with me. I don't spend 51 on buying the lottery. I just keep that 100 as is. So if I keep those 100 rupees as is, what will be my utility? My utility from not buying the lottery, it is given by 10 root x, and x in this case will be 100. I did not touch my 100 rupees. I didn't spend that 51. In this case, I spent 51. I earned 351. I spent 51. I lost the entire money. Here I'm not spending any money. So here I will get 10 into 10, which will be 100. So this will be my payoff when I do not buy any lottery. And this will be my payoff when I buy the lottery. So what do I want? I will buy lottery if my expected utility from buying lottery is greater than my expected utility from not buying lottery. As long as I have this, I will go ahead and I will buy the lottery. So I will have 130 P plus 70 greater than 100, or I will have P greater than 30 by 130. So P greater than 3 by 30. Then I will go ahead and buy the lottery. Few points that I must tell you. First of all, few students, the mistake that they have been doing while I analyze the exam is that once they find expected utility and they read this word that A is utility maximizer, they try to maximize this utility with respect to P. Just think about this. P is the probability of you winning or losing a lottery. P is not under your control. P is exogenous. When you toss a coin, whether head will come or tail will come is not under your control. So whether you will win a lottery or not win a lottery, whether it will rain or not rain, that is not under your control. And any factor which is exogenous, you cannot differentiate your function with respect to that. So keep in mind, please note this down, never differentiate this with respect to P. This is not the meaning of utility maximizer here. I cannot, and it's a linear function. If I differentiate and equate to 0, I will never get a value of P. I will simply get P is equal to 0. Don't do that. Second thing, a lot of times this happens in DSE. Whatever answer you may get, I don't know why they do this, will not be one of the options. It will be a higher value. You know, they would have changed the fraction by multiplying and dividing the numerator and denominator by something or the other. So for example, if I go back to my question, and I showed you for one more case, I remember, ideally, P greater than this, 221, this is 551 by 221. It is the same that the answer we got. We just got P greater than 3 by 13. If I multiply both by 7, I will get P greater than 51 by 221. So the answer is D.